Okay, we're starting lesson 4.4, struggling through the warm-up. Okay, what I did see was a lot of us had this. This is beautiful. Let me just read it out loud quick. We have this lighthouse, 200 yards from a bike path along the edge of the lake. A walkway to the lighthouse is 400 yards long as shown. Find the acute angle theta between the bike path and the walkway. This is right here. Okay, here's what I saw. A lot of us had this. This is beautiful. That we knew the sine of that angle would be the opposite distance over the hypotenuse, and they kind of drew that right triangle for you. So if you got this far, this is good. Reduce this to 1/2. Now, yes, you can use that inverse sign in your calculator, but this is one we kind of have to know. This is one on our unit circle that when I take the sine of this acute angle, when do I get 1/2? So I pulled up my unit circle here. So obviously all of my acute angles are these ones in quadrant 1. So which angle gives me a sine value of 1/2?
60.
Sine is what?
It's like excellent.
It's echoing.
30.
It was. I heard it before.
Was it me that was echoing?
Yeah.
Oh. Okay. Well, if it does it
30
again,
degrees.
I'll see if I can adjust it. Yeah, 30 degrees. Okay. So this is one of the exact values that we kind of have to just know or recognize that this would be 30 degrees. But yes, there is a way to type it in your calculator. I can show you that quick by doing the inverse sign. Now, when we're talking about angles in a triangle, we obviously want degree measures. Okay, the only time we use radian measures is when we're looking at like central angles in relation to like a circle and the radius. It's what a radian is. But in your calculator, just make sure you're in degree mode. And you can do the sine inverse, like which angle gives me the sine ratio of 1/2. It'll tell you 30 degrees. But you have to be able to like solve those types of problems without a calculator too. Okay, so I liked that problem because I haven't really quite shown you like how to solve for the angle yet. But with our practice of the unit circle, wanted to see if you maybe recognize that, and some of you did. So good job. Okay, there's the warm up. So 4.4. We are going to evaluate any like trig function in inverse 6 of any angle given to us. I'm going to introduce you to something called reference angles. A little bit of calculator work, but mostly non-calculator work. Okay, so we've kind of done this before with the unit circle to kind of discover that sine was y, cosine was x, and all that stuff. But now you might be given some coordinates where your angle lies in standard position and intersects a circle, not necessarily the unit circle. Okay? So really quick down here, we know the equation of this circle right here. It's still centered at 0, 0, right? So it'd be x squared plus y squared equals my radius squared. That's the equation of a circle centered at 0, 0. All right, so if I have some angle, let's just draw it in quadrant 1, and its terminal side intersects this circle at x comma y, we can form this right triangle. Okay, kind of done this before, but we did this with the unit circle, so here's how this is different. It might not always be a unit circle, meaning this radius right here for now is not, it's not 1. We don't know what it is, and that's gonna maybe change. Okay. If I wanted to find like that actual distance of the whatever the radius is, I could solve this for r quick. So I could square root both sides. It'd just be the square root, and we're only going to use positive for now. But that radius would just be the square root of x squared plus y squared. Okay. So basically what they want you to see here, and as I mentioned, we've kind of done this before, this distance would be x. If that coordinate was xy, this distance would be y. So if I want to evaluate my 6 trig functions for this angle theta, we can use our right triangle trig. All right, let's do sine with starting with SOHCAHTOA and then just doing all the reciprocals. Sine is opposite over hypotenuse. Here's my only difference. This hypotenuse is not 1. It's whatever the radius is. Okay, with the unit circle, we were just like, oh, the radius is always 1, so sine is just the y-coordinate. Now we're just going to take it a step further and look at like different types of circles, I guess, or different types of terminal sides. Cosine would be adjacent over hypotenuse. And you don't have to like memorize these by any means. I mean, you already know sine is y and cosine is x, but a lot of times I just draw a picture and I just draw a right triangle. Tangent, opposite over adjacent. And then we can just do all the reciprocals. These ones are kind of in a weird order. Cotangent, tangent's reciprocal, so x over y. Am I still echoing, or did it kind of stop? It stopped, okay. Secant, cosine's reciprocal, r over x. Cosecant, sine's reciprocal, r over y. All right, now, the signs of these ratios, and this is the part where you're like, okay, yeah, same thing as right triangle trig. But this terminal side could be like anywhere if we draw this in standard position on our coordinate plane. That's what standard position means, right? Anywhere on this like XY coordinate plane. So this part they're kind of saying here is like the signs of these might change depending on where your angle is or like kind of what quadrant you're in. If I have something over here in quadrant 2, I might have now some negative x values and the cosine ratio is going to be negative. And you've never seen like negative ratios when we like apply it to right triangle trig. And drawing angles in standard position like allows us to take that a step further. So let's just try one and you'll kind of see what I mean. And like I said, a lot of times I don't even really like have to memorize this if you understand your right triangle trig and you can kind of just like sketch a picture. So here this one's saying, let negative 3,7 be the point on the terminal side of your angle theta. Find the exact values of the 6 trig functions of each angle theta. Okay, so let's draw a picture here. Oh, negative 3,7 would be, let's draw a general sketch, up here in quadrant 2, right? Okay, so they're telling you that is the point of your terminal side of theta, meaning I would start where I normally do with my initial side here, and my terminal side would rotate and it would end up here somewhere in quadrant 2. So note this like isn't my unit circle. There's something different. They're just saying here's your terminal side, so this right here would be your angle. Okay, so what they want me to do is find the sine of theta, cosine of theta, tangent, all 6. I expect nothing less. Cosecant, secant, and cotangent. All right, now based on what we just talked about, you could say, all right, well, sine is just my y-coordinate divided by r, and they're like, wait a minute, what's r here in this case? Well, this is where I kind of just draw a picture to help me. We're going to get talking into reference angles in a little bit here, but what a reference angle is, it's like the angle formed by the terminal side and the x-axis. And this we can relate to what we know about the unit circle. So we know on our unit circle, like if I'm 30 degrees above the x-axis over here in quadrant 1, I have the same coordinates, the same xy coordinates as I do when I'm 30 degrees kind of away in quadrant 2, just the signs are different depending on what quadrant we're in, right? We know that pattern. So that's what a reference angle is. This reference angle is 30 degrees, 30 degrees, 30 degrees, 30 degrees. So I was kind of referring to it earlier as like you have the 30 degree angle of quadrant 3, it's like 210 degrees. So this reference angle, if it's 45, 30, whatever it is, no matter where it's at in which quadrant, it's going to have the same coordinates, okay? Just like different signs depending on where it is. So what we can do here is we can still draw a right triangle, and you're going to drop it to the x-axis here. You can still draw my right triangle and use this angle as almost like our reference angle here, and we'd get like the same trig values. Okay, so I think this is the easiest way to do it is draw a picture. So here, if this point is -3, 7, think of how I would plot that point. What would this distance right here be? -3. This is the part where students are like, what the heck? How can I have a -3 side on a right triangle, right? And that's why we can evaluate it is by positioning it on this standard position. This is like how we can do that, okay? And then this distance would be what? 7. So this right here is what we call like our R, our radius. If we were to, draw this on a circle, you don't have to, but if we were to draw this on a circle.
Quick question.
Yeah.
So even if you had a positive 3, wouldn't you just be able to subtract like what you got for theta, that angle? So 180, subtract that number to get.
Yes. Yep, that would work. We're going to get to that in a second. We'll talk more about the reference angle, like why this works in a little bit here. But think of like the Pythag theorem. Like that would still work even if we have negative side lengths, right? So to find this is what we kind of call the R. To find this R, we can still do -3 squared. And we can still figure out what that side is. Question? Okay, hold on. We'll get there. So we get the square root of 58 as this distance right here. That can't really be simplified. And now you're just doing all your right triangle trick to find that instead of like essentially like memorizing this. Okay. And this is like the same thing as a unit circle, Connor, where like think of more as like sine is like the vertical distance and cosine is the horizontal distance. It's not, don't think of it as a distance. So don't draw a right triangle if that confuses you. Then you just have to know that the cosine is the x coordinate divided by the r coordinate. The x coordinate's negative. So you have a negative cosine value here in quadrant 2. If that doesn't make sense to you. But you can draw this right triangle because of something called a reference angle. I just don't love this because you don't know what reference angles are yet. But once we learn what that is, that kind of like connection will make sense. But okay, so let's just go through and I'll kind of try to explain it more as I go. So the sine of theta, you can use like this reference angle. You can use your knowledge of right triangle trig is opposite over hypotenuse. And that's essentially the same thing that they're like telling you here, that no matter like where you are in standard position anywhere, the sine of the angle is always going to be the y coordinate divided by whatever the r is. R talking about like the radius of this circle. Okay. I do have to rationalize this. Let's give myself a little room here. Times the top and bottom of the square root of 58, you get 7 root 58 over 58. Okay. So cosecant, let's just do that one right away. I would just take the reciprocal here, square root of 58 over 7. Okay. Cosine, either memorize, it's the x coordinate divided by this length right here, this radius length. Another way you could solve that radius length is by like plugging it in your equation of like the circle, because that's where it's intersecting. But again, I just like to draw right triangles, and then you can kind of visualize it. Cosine adjacent over hypotenuse. Rationalize that. We end up getting negative 3 root 58 over 58. Okay. Tangent, opposite over adjacent. Now we typically don't write negatives in the denominator, so I probably just write it out in front. Negative 7 over 3. All right, so we have a negative tangent value as well. And reciprocals. This would be negative 3 over 7. This would be negative square root of 58 over 3. That's a 5. Okay. So basically what they're trying to show you here, guys, is like they're going to give you some location on the coordinate plane where this terminal side of your angle ends up. Okay, so it can end up here in quadrant 1. And that's why it's nice to visualize this, because you're used to seeing positive distances with the right triangle. But now we can position this anywhere. Okay, and just like our unit circle, I could really technically do that. Like I could draw right here. I could draw a little right triangle. This is like 30 degrees here. And this is 1. And then I have like my right triangle ratios that, okay, well, this distance is always half of the hypotenuse across from the 30. This is always the square root of 3 times this distance, special right triangles. So to get this ordered pair, I travel negative square root of 3 over 2, positive 1/2. That could be like another way to like get that ordered pair. Does that kind of make sense? So basically, they're going to give you the ordered pair, and you have to find all of the trig values. So instead of like I said, instead of like memorizing those formulas, just draw yourself a little picture, and then keep in mind you're really not finding the lengths of the triangle. You're just more finding like the horizontal and vertical distance depending on where you're located. If that makes sense, because that's what sine and cosine are when we're looking on a coordinate plane. When we're looking at a right triangle, that's not about right. 25. Okay, we got 10 minutes. When we're looking at a right triangle, and that's what we did last lesson, we're always obviously going to have positive values because we're talking about sides of a triangle or like application problems too. If we're talking about like distance, you're right, we can't have negative distance. But now we're relating it to a coordinate plane where, again, instead of like thinking of it as like distance, think of it as almost like the length. That's probably not even better either, because you can't really have negative length. The vertical value, the horizontal value, maybe. And in a coordinate plane, we can have negative and positive horizontal and vertical lengths, positions, movements. I don't know. Does that kind of make more sense?
Sure.
Yeah.
It's basically what they want you to notice is like how we can have different trig values and where their signs are depending on where it ends up in each quadrant. And you kind of already know this because you know a little bit about the unit circle. So you know that sine is y. So all of these y coordinates are positive in these two quadrants, right? So that's why when I found the sine and its reciprocal of an ordered pair that ended up in quadrant 2, like those ended up being positive. Okay? My cosine values, if I end up in quadrant 2, those are going to be negative because we know cosine's like our x coordinate, kind of like location. Maybe think of it that way. And then tangent is y over x. So if I have a positive divided by a negative, so here, another way to get tangent, we could have just done y over x. Okay? I just think it's easier, especially coming off of right triangle trig with these types of problems, when they give you that position of where it ends up, and there's some on your homework, and you can decide how you like to do it. Instead of like memorizing another thing, just draw yourself a little right triangle and do like your SOHCAHTOA. That's what I mean by that. Okay. Like I said, I don't love that you don't know what a reference angle is, like why this works, why we can like use this angle instead of this angle. Hopefully after like tomorrow, once we talk about what reference angles is, maybe that'll make more sense of like why we can do that. But this like works, and you already know kind of this from your unit circle. So it's just applying it now to other points that aren't on the unit circle. Okay. Do we need to try another one?
Good question.
Yes.
So, when you use a reference angle, you always make the adjacent side negative?
It depends where we're at. So let's try. Let me just like give you another example quick. You don't have to like write this down. Just look up here for a second. If they said the point is -4, -11, okay, is that on our unit circle? No, it's not. It's not one of those special ratios. So I'm going to have a different kind of like circle, a different radius. It's not going to have a radius of 1. If I were to just quickly, obviously going to be down here in quadrant 3. So I'd have this angle right here. This is theta. So they're saying,
How do you know where to put theta?
well, you always go this way when you put something in standard position. You always
Theta would be above or below?
you always start here and you rotate this way.
Wait, so would you put the 90 degrees? Would you go from your point to the right?
Nope, you always go to the x-axis, and that's what a reference angle is. That's what you don't quite know yet, but you will soon. Okay, so we go this way, right? And
yeah, I get that now. I was thinking put it to the y.
okay, so yeah, I'm saying like this will, instead of like memorizing like, oh, I have to find this length and using this equation of the circle because it's really intersecting a circle. Like instead of doing that, drop a perpendicular side to your x-axis. Use the reference angle here, call this theta, and do your SOHCAHTOA to find them. I just think that's easier. But if you want to practice it on your homework and try it like by using the equation and just like kind of like memorizing those, that's fine. But now, okay, let's talk about what like this. What's a better word to call it than distance? This location.
Section.
What would this location be?
-4.
-4. What would this?
-11.
-11. So then you could still do Pythag to solve this. You're going to get a positive value, right? And then to find sine, you just do -11 over this. And you're going to get a negative value, which makes sense because sine on your unit circle, all the y coordinates are always negative down here. Okay? The other way to do it, and I don't want to like confuse you, the other way to do it, this is the way your textbook does it too. I just don't love that you don't know what a reference angle is yet, but you will soon. The other way to do it though is to, like I said, find the equation of this circle, which is x squared plus y squared equals the radius squared, which is the same thing as the Pythag. Here, plug it in, you'll figure out what your radius is. And then just know, oh, sine is -11 divided by my radius. Which, you do that in the unit circle, your radius is just 1.
Yeah.
You know? So, okay, cosine is x divided by the radius. This just is a nice way to like visualize it. But I see how it can be confusing because you're like, wait, I can't draw a right triangle with negative lengths. And think of it more as like a location. I'm trying to think of a better word. What do you guys, any ideas? Do you know what I'm trying to say?
Yeah.
Okay.
I'm basically just ignoring the negatives at this point.
And you kind of can. Just what they're leading into is this next. This is important. This is what they want you to like see by doing a problem like this, is that our trig functions have these like patterns of where they're positive and where they're negative depending where we're at on the coordinate plane or what quadrant we're in. All right, and we can again relate this to what we know about the unit circle. So you guys know the 4 quadrants go this way: 1, 2, 3, 4. Right, that's how we number our quadrants: 1, 2, 3, 4. So in quadrant 1, and think about what we know with the unit circle. The sine is always the y coordinate. The cosine is the x coordinate. And tangent is y over x. So wherever we're at in quadrant 1, I have positive x coordinates and positive y coordinates. And if I have a positive divided by a positive, what am I going to get? Positive. So if my angle's in quadrant 1, everything's going to be positive. All trig functions. And again, draw a right triangle in quadrant 1. These, I can't think of a word. locations,
Segment.
but you can't have negative segments either.
Oh, that's so stupid.
So I'm like
Practice
length,
stupid.
distance,
Contradicts yourself.
legs, these values,
Sure.
it's going to be
Works.
positive and a positive, right? And this will be positive as well. Okay, so then if I'm over here in quadrant 2 and think sine is y, so think of just like your y-axis. My sine values are still going to be positive up here. Cosine's going to be negative, yep, because now this x distance is negative. X value is now negative. And tangent, positive divided by negative, is going to give me a negative. And that's kind of what they're trying to like introduce you to here. Like, look, when something ends up being in quadrant 2, all 4 of these are negative. And their reciprocals obviously like follow the same rules. Okay, so that's why they're kind of listing both. All right, we'll pick up this conversation tomorrow. Good start.
Yeah, this is stupid in context, so.